based on the parts of the JavaScript workshop that you already have access to. Today we're going to talk about debugging, we're going to talk about loops, and we're going to talk about booleans. Now, those three things seem a little bit unrelated, and in some ways they are. But in terms of kind of covering materials, these are also three concepts that we think are actually very fundamental to you being able to use JavaScript in general, regardless of whether you're working on the front end or the back end, or just kind of operating under any set of circumstances. The first one, debugging, it is more, it's, as you can imagine, debugging just means troubleshooting, aka fixing code that doesn't work the way that you expect it to or the way that you want it to. The debugging is definitely more of an art than a science in the sense that there's no foolproof formula for doing this that resolves in you writing code that either doesn't break that results in you fixing code that's already broken. When I say it's more of an art than a science, what I mean is after a while, as you write more and more code, you actually start developing an intuition for based on the types of errors that you get or based on kind of what goes wrong. You develop an intuition for understanding where the issue most likely is and then how to solve that issue. Developers spend way more time debugging code than writing it, and so I would almost say that ratio is very heavily skewed. For me, usually, if it takes me, let's say 1 unit of time to write a piece of code, it might take me 2 or 3 units of code to debug it, test it, run through it, figure out other parts of it too. So don't be discouraged if you find yourself fixing code, as probably you've done in the earlier workshops. It's very normally part of it's very normal and part of the process. The most important part when it comes to debugging code is understanding the error messages understanding the error messages that pop up. After all, it makes sense, right? How do you fix what's broken unless you know what's broken? Error messages are very common in JavaScript. So we talked earlier about how HTML doesn't really have any error statements. It'll just render the code, and if it's wrong, it'll just look bad. JavaScript will actually tell you in a lot of cases when your code is wrong. As in it will refuse to run until you fix the errors. One of the things to know is that in most cases, when you get a error in JavaScript, it never just says, "Hey, this is broken." Most code editors and most in JavaScript environments nowadays will definitely give you some kind of idea as to what actually went wrong and where you can start looking to fix it. So here on the right hand side, what we're showing here is something called a stack trace. What a stack trace is it tells you what the error is, and we see that on lines 3 and 4. That tells you what the error is, but more importantly is it will also tell you where or how the code got to that error, i.e. which lines of code were run before we end up triggering or hitting that error. And if you think about it, it's actually very helpful to us, right? Because so far what we've done is we've probably written very simple, 3 or 4 or 5 lines of code. If I have a page of code with 1,000 lines of text, well, if JavaScript just says, "Hey, this is not working," it doesn't really help me, right? I don't actually know where to start fixing it. So what a stack trace is a stack trace will actually tell you, "Hey, I tried running line 5, which then made me run line 4, which then made me run line 999, and that's where the error happened." And so when we look at the right hand side here, notice how the way that the stack trace works is it will show you the most recent line that ran before it got to the error first. Then it will show you the most recent line before that, and then the most recent line before that. So the lines at the very top are quote unquote the most recent. And so when we look at line 5 there, that is the most recent line of code that ran before we got to the error. And if you look at it, this might be a little bit hard for you to parse out right now, but just kind of, for now, just take it for granted that we're going to skip past the localhost 73557 backslash. And notice how after the backslash, there's this file called only-odds.js or onlyodds.js, followed by a colon, followed by 2 numbers. The onlyodds.js tells us which file is actually being run right now, which is very useful when you're dealing with a very complex app, or we're dealing with a complex application that has multiple files. The first number after the colon tells you which line of code was last hit before the error got triggered. And then the number after that tells you which character was hit before the error was triggered. Usually we don't make use of the line of the character that much. Usually knowing which line at which the code broke down is sufficient for us to start our investigation. Now, the line number is a really good place for us to start figuring out what happened, because that's kind of where the error kind of started manifesting itself. But just note that just because the error occurred there, it doesn't mean the error was caused there, right? So if I think about if I think about an airbag in a car that doesn't go off, right? The airbag didn't go off at the point of the crash, but that doesn't mean the airbag was miscreated at the point of the crash. It was actually miscreated in a factory somewhere, right? And so even though we saw the error occur at a certain line, that should tell us we should start our investigation there. But it's not a definitive, concrete thing that says the error has to be here. So the two types of errors that we'll talk about today are very basic, and there's literally dozens, if not hundreds, of errors out there. So we're by no means trying to be exhaustive. We're trying to get you to understand the two main types that you'll see probably as you start your coding journey. The first one are just very simple syntax errors. These are the things that beginners tend to make mistakes on because there are things like misspellings, typos, syntax errors. These are things that as you write more and more code, you'll just start realizing you'll start one doing them correctly just out of habit, and then two is when you look over your code, you'll start kind of intuitively realizing, hey, this looks wrong, this spelling looks off, this semicolon or this bracket or this brace looks misplaced. And so helpful things to include when you come across the syntax errors are make sure all your braces, brackets, and parentheses are open or closed in the right order. Okay. So remember how we talk about how with code, right, it reads it from left to right, top down, unless, for the most part. And so if I have a parentheses here and a bracket here, the parentheses has to close before I close the bracket, right? Like the brackets and parentheses can't be intertwined. And then secondly is make sure all commas, semicolons, and arrows are properly used too. We haven't talked much about arrows so far, but just as you do it, make sure that when you're writing different types of formulations, that the different types of syntaxes are correctly used. A lot of times, folks like to copy and paste code because it helps them kind of not have to memorize how to write some of the syntax. But trust me, you'll want to know how to do it by hand. It's just it'll make your code a lot more understandable to yourself at the very least. The second kind of errors that we come across are something called reference errors. This is when the code says, hey, you're trying to use a variable that doesn't exist. Okay, that explanation or that error can be a bit mysterious. And the most common reason, so there's two main reasons for that error. One is that you're trying to use an error outside of the proper scope. And we haven't talked about scope yet in this class, nor will we. But just know that usually happens is when you try to use a variable before you've properly created it, or you're using it outside of the environment in which it is able to be used. Okay. That error you probably won't come across too much in our curriculum, just because we don't deal much with kind of creating multiple nested scope scenarios. Instead, the most common error is probably if I create a variable called water, water, and down the road I somehow misspell it and I call it watr. Well, JavaScript doesn't know that I misspelled a word. It will think I'm literally looking for a variable called watr, and it will give me a reference error saying, hey, that variable doesn't exist. And so for the most part, when you see reference errors at this stage, there's a very high chance that usually it's a spelling related issue. Okay. Once again, these are two very, very basic examples of errors that you'll come across. You'll definitely come across a lot more different types of errors, but we just kind of want to walk you through what are some of the more common things that you'll see in the beginning. Okay, the next topic we'll talk about are loops, or in this case, conditional statements. Conditional statements, as the name implies, are statements are based off of conditions or situations, right? What is a condition? A condition is a criteria, right? If you think like a contract or an agreement or a negotiation. What conditional statements do in JavaScript is they allow you to control the logic flow in our programs. So you can think of a conditional statement very much as if it was a fork in the road, right? We've reached a certain point, and now based on the condition, we either go left or we go right. We either choose point A or point B. The most important thing to know is that we can't do both. Okay, and this actually makes our code really powerful because now we can actually say, based on certain things, based on a certain input or based on a certain value, let's do this instead of this, rather than let's just do the same thing uniformly throughout. Okay. To write a conditional statement, we'll use two keywords, if and else. Oh, sorry. So on the right-hand side of the code here, you'll see on line 1 and 2, I've created two variables, num1 and num2, and assigned them numerical values. Okay. On line 4, I've now started creating something called a if-else statement. An if-else statement, if you think about the way that we say that even in English, right? It's pretty much like, if this happens, do this, else do this other thing, and that's exactly how the logic that's exactly how the logic behind a conditional statement really works here. On line 4, we have an if statement, and in between, after the if, notice how we have this set of parentheses. Inside that parentheses is basically our condition. Is that condition being met or not? Is it true or is it false? In this case, in between the parentheses, all I've done is I've put in true, which means uniformly this thing is always going to be true. Okay, so if this thing is true, what do we want to do? Well, we do what's in the curly braces that follows line 4, right? So we have the open curly brace on line 4, we have a line of code on line 5, and on line 6, we close the curly brace. So that means if this thing in between the parentheses is true, which it is, we'll do line 5, which console logs out, I run this code. Otherwise, aka if the thing in the parentheses is not true, we go to the else statement on line 7, and then we put an open parentheses there, and we console.log out, not this code, and we close our parentheses, okay? So now we've essentially created a fork in the road, right? And the fork says, if this condition is true, do line 5, otherwise do line 8, okay? One thing that people get tripped up on here is usually they say, well, otherwise, do I need to specify, what otherwise means? And the answer is not in this case, right? If you think about it, the thing we're checking for is pretty simple. If the thing is true, let's do this. We don't care if it's a number. We don't care if it's some other value. As long as it's not true, we're not going to do it, right? So any other value is fair game. Now, sorry. Okay, so if we do want to think about a way to kind of make our trees a little bit more robust, let's take a look at the example on this page. On the top half of the page, notice how on the left-hand side in the gray box, I still have a very simple if-else statement, right? It says if, and now in my parentheses, I have this statement that says 9 is greater than 8. And what I want to do is I want to check if that statement is true. If 9 is greater than 8, I want to console log out, this is true. Else, I want to console log out, this is false. And so if I look on the right-hand side here, we can kind of see that's kind of how my fork in the road is formed, right? My initial check is just to make sure, is 9 greater than 8? If it's true, we'll console log out, this is true. If it's not true, right, we'll console log out, this is false. That's a very, very simple fork in the road. What JavaScript also allows us to do is actually make more and more complex forks in the road. So one thing we can actually create something called an if-else-if loop. Okay. If I look in the bottom half of the page now on the left-hand side in the gray box, if I look at the first line, I still see my same if clause, right? And if clause says if num, this variable called num, if num is greater than 8, we're going to console log out num is greater than 8. Else if num is greater than 6, we're going to console log out num is greater than 6 and less than 8, right? Here, what the else if allows us to do is basically make another if condition, right? We've already established that num is not greater than 8, because if it was, we would have run console log and then our loop would have ended, right? Here, what we're saying is, well, if it's not greater than 8, is it greater than 6? And we've now reached another fork in the road, right? And if it is greater than 6, then we'll print out num is greater than 6 and less than 8. Otherwise, we're just going to console log out num is less than 6. So if I look at my tree on the right-hand side, it follows the very similar logic, right? My first check is just, is num greater than 8? If it's true, we'll console log out num is greater than 8. If it's not true, well, then we reach another fork in the road and says, well, is num greater than 6? And if it's true, then we'll console log out num is greater than 6 and less than 8. And if it's not true, we'll just console log out num is less than 6. Okay. The most important thing to remember in any conditional statement is that even though there might be, and one other thing to clarify is that we can have as many else ifs as you want, right? We can say, if num is greater than 8, do this. Else if num is greater than 7, do this. Else if num is greater than 6, do this, and so on and so forth. We can have as many else ifs as we want, but we can only have one beginning if statement, and we can only have one else statement. Okay. The most important thing to remember in any conditional statements is that even though we have so many options to choose from, we can only ever do one statement in a series of conditional statements. So here on the if else if else tree or statements there, even though there's 3 different console logs value, If we run this code once, only one of those values will ever print out, or only at most one of those values will ever print out. Any questions? Everyone good? Cool. Okay. Well, so if I already said, if this thing is true, we'll do this. Well, how do I actually do that check? How do I make sure something is true? And so here's where comparison operators really come into handy. Comparison operators are basically ways for us to compare two different values. There's a few comparisons, and we'll just go through them really quickly. The most important one, and one that you probably use the most commonly, is just this 3 equal signs in a row. In JavaScript, remember that 1 equal sign is not a comparison. 1 equal sign is an assignment. That's saying I give the value of whatever is on my right-hand side to the variable on my left-hand side, okay? So don't get tripped up there. When you're trying to compare things, always use 3 equal signs to check if two values are equal. The exclamation mark is called a bang, and we'll talk about that in the next couple of slides. But a bang equal basically checks if two values are not equal. So if these two things are not equal, this will return a true. If they are equal, this will return a false. And then we have our more traditional math operators that hopefully everyone's more familiar with, the less than or less than equal to operator, as well as a greater than or equal to operator. So these 6 operators are pretty much forming the foundation for most of the things that we're going to take a look at in this curriculum. And so we're just checking for whether or not something is equal, whether or not something is greater than or equal to, or less than or equal to. And so the last thing we're going to talk about is this idea of true. What does true mean? Okay. In JavaScript, there's this idea. So one of the data types we talked about on Wednesday, or last Wednesday, was something called a Boolean, right? And if you remember, a Boolean only has 2 possible values. Something is either true or something is false. There is no middle ground. And so because of that, Booleans, everything in JavaScript can be converted into a Boolean. Right? And when you convert something into a Boolean, it has, as you can imagine, 2 possible values, either true or false. And so for the values in JavaScript that when I convert into a Boolean, they become true, those values are called truthy or truth-like. For the values in JavaScript that when I convert into a Boolean, they're false, we call them, as you can guess, falsy or false-like. Now, most values in JavaScript are truthy. That is, if I have any string value here, so here on line 3, I'm converting the string I am a string into a Boolean. Don't worry too much about the conversion for now. Just kind of understand that what we're trying to show you here is that a string with values, a number, an array, an object, these are all truthy values. That is, if I took any of these values and I converted them into a Boolean, I would get back a true value. It's actually much easier for us to understand what the falsy values are JavaScript and work backwards from there. So what does that mean? That means that if I try to convert an empty string into a Boolean, I will get back false. Well, that also means that all other strings, so any string with any value, is by definition going to be true. Similarly, the number 0 is false if I convert it to a Boolean. So is null, so is undefined, and so is this NaN thing, which stands for not a number. We're not to talk too much about it now, but just know that these are the quote-unquote falsy values in JavaScript. Every other value of JavaScript is truthy. That includes empty arrays, truthy. Empty objects, truthy. Functions, truthy. Everything is truthy except for these 6 values if you include false itself. Okay, so I'll just say one more time. The only false values are empty strings, the number 0, nulls, undefined, not a number, and then the actual value false itself. So then if we have this kind of very binary relationship between true or false, aka if everything in JavaScript could either be considered true or false, how do we switch between those two? And the quick answer is we have this exclamation mark, or we call the bang operator, or sometimes also called the not operator. What the bang operator does is it basically takes a value and it gives you back the Boolean value that's the opposite of whether or not it's true, right? That's why we call it the not operator. It's the opposite. It's the not of what you think it's supposed to be. So here, if I have a true value and I put an exclamation mark in front of it, that's going to give me a false value. On line 6, I have this string ABC. Is the string true or false, right? If I convert it to Boolean. Well, it's true because the only false string is an empty string, and this string is clearly not empty, so therefore it must be false. Here, same idea, right? What numbers are false? The number 0 is false, and not a number is false. Every other number is true. So therefore on line 8, 100 is by default true, and so when I put an exclamation mark in front of 100, that says not true, so i.e. false, and so on and so forth. And so what the bang operator does is it gives you the Boolean value that's the opposite of whether or not a particular value is truthy. Sorry if it's causing you some headaches. Like I said, this material is a bit dense, right? Because there's a lot of this like flipping back and forth, and it's something that I don't have any kind of silver bullets for you, other than to say that the more you do it, the easier it'll get. But in the beginning, it definitely is a bit of a headache, and I totally understand that. And then if we'll get to our old friend here, right, the double bang operator, right, the not. This one is also a little bit tricky to think about if you try to think not. The easier way to think about it is just, is this value true or false? If it's true, then we'll just give you back true. If it's false, we'll just give you back false. And so on line 4, if I remove the 2 exclamation points and I say, is true or false? It's true. So not true is false, and then not true is true again. Similarly, if I'm my string ABC again, well, 1 exclamation mark in front of this. So ABC, by definition, by default, the Boolean value of it is true, the truthy value. So 1 exclamation mark will make it false, and another exclamation mark will make that false true. Right? And so these are all truthy values by default. And so when I put 2 exclamation marks in front of them, what I'm really doing is I'm just converting all of them to true value. I'm saying, hey, give me the opposite of your opposite Boolean value. Okay, almost done, I promise. The last two things we'll talk about then are two more operators. The first one is called the AND operator, and the AND operator is written as 2 ampersands. And what it does is it actually allows you to check multiple items in sequence. So if I think about something simple like a grocery list, right? If I say, I need to bake a cake, can you go to the store and get me milk and flour and eggs? Well, if you come back with just 2 of those 3 items, I can't bake a cake, right? Like I need all 3. It's all 3 or bust for me. And so here, what the AND operator does is it's from very similar, right? On line 4, on the left-hand side, I've created this variable called return value 1. On the right-hand side, the first thing I check is 10. Is that true or false? If it's true, then the AND says, check my next value, which is a string apples. Is that true? Okay, that's truthy enough, right? Because it's a string with characters in it. The only falsely strings are empty strings, and that's clearly not an empty string, so therefore it's clearly not false. Great. Check the next thing. The next thing, if I keep going to the right, it's number 0. Is 0 truthy or falsy? Well, 0 is one of 2 falsy numbers. And so at that point, the AND operator says, okay, I can stop looking. I found my first false. Why is that important? Because if I have a list of 4 things and I need all 4 of them to be true, well, the first time I find a false value, I don't have to check the rest of the list anymore because I've already verified that at least one thing is false, and therefore there's no way your list can be complete, right? And so if we look at line 1 here, what we wrote down is the AND operator returns either the first falsy value it finds or the last value if all the values are truthy, which is what we see on line 7 here. On line 7, if I was using AND operator, I would check, is my first value truthy? Well, my first value is a string lucky, so that's truthy. Okay, great. Let's check my second value, the string number. Is that truthy? That's also a string with characters in it, so therefore it must be truthy. Okay, check the last thing. So number 7, is that truthy? Yeah, it's not 0, so it's truthy. And so therefore, on line 5, when I return this value, I return the first false value I find, which is number 0, because it tells me, hey, I stopped looking at 0 because I came across at least one false. There's no way everything in this list is true. On line 7, then I did something very similar where I say, hey, I checked the entire list. The last value was also true. And by virtue of me making to the last item in the list, that means everything else that came before it was also true. And so therefore, that's a truthy value. And so then the last opposite of the AND operator, if you can imagine, would be the OR operator, right? So if I send someone to the store to buy me some drinks, right? If I say, can you bring me back Coke or Sprite or seltzer, right? I just need at least one of those things to be valid. And so with the OR operator, which is written as two vertical lines, which we call pipe symbols, if you look on your keyboard, they're usually located right underneath the backspace or the delete key on your keyboard. What these two pipe symbols, what the OR operator says is it will give you back the first truthy value it finds, or if everything in it is false, it would give you back the last falsy value, right? Because remember, OR just means I need at least one of these things. So as soon as I come across one truthy thing, I'm done. I don't have to look anymore, right? I found at the minimum of what I need. So here on line 4, if I look at the first value, which is a null value, that truthy or falsy? Well, that's a falsy value, because if I convert to a Boolean, it would be a false. Okay, so let's look at the next thing. The next thing is undefined, which is also false. So let's look at the next thing. The next thing is a string happy. And happy is a string with characters in it, so therefore it's truthy. And therefore I can stop looking right there because I found at least one truthy value, and that's all I need. Similarly, on line 7, I do the same exercise, except now the first value is false, which is falsy, null, which is falsy. The third thing is actually an expression, right? It says 10 is less than 0. Well, that's not true, so it's false, right? And then lastly, I come back to our old friends, not a number. And so everything in this list is false. And so therefore, on line 5, when I return back the value, I get back the string happy, because that was the first truthy value that I found. And on line 7, there were no truthy values, so I just return back my last falsy value, which is not a number. So that's it for today, right? Fairly dense, a lot of topics, a lot of things to work your mind around, but also just a really good mental exercise as you kind of start working on things that aren't so linear, because now what we've done is we've actually introduced a way for you to kind of create branches or forks in your code so you can make different decisions depending on the different circumstances. Are there any questions before we separate and work on the workshops?